Hola, ¿ya estás preparado?
Ya estoy conectado, listo.
Okay. Then we start with the conference of Andres, and if you are ready, you can start, and we see your with your presentation, and we can see you in one corner. Okay, let's start. Thank you.
Okay, I'm not hearing very good the audio from you, but I hope you are hearing me good. So
Good.
Let's begin. I don't understand.
Yes, we te escuchamos un poquito regular, pero bueno, you can start.
Okay, so welcome everybody. I hope you're going to understand me. This is the first time I'm going to show you this new, I don't know, software, something like that. I create to compare origami crease patterns. I'm Andres Sanchez. I'm a biologist, and I have been an origamist from all my life. Maybe some of you already know me, maybe other not. But this is, I want to go to the convention, but I can't. I have in this moment to finish my PhD, so I propose this virtual talk. So I hope you enjoy it, and I hope we can share some ideas of this proposal I'm doing. So I hope you like it. So we can begin thinking about the crease patterns as we can unfold a given model, a given figure, and we can translate these into lines. And these lines represents all the folds that we can find given the structure of a given origami figure. We can use different notations and symbols of this in these crease patterns. Usually we can use different kinds of the thickness of the line. In this case, is maybe our more thicker line representing the mountains, and thinner representing the valleys. We have other options like the coloring the CP. We are using CP for crease patterns as we are showing in red and blue, and there is other option using everywhere. So what is my question here? My question is about how we can use these crease patterns to compare different figures of origami. Is a question I have from so many years, and recently, the last year, I managed to apply a mathematical method to compare this. As I'm trying to discuss later, this has a different application in origami designs, maybe even in the copywriting, so something like that. We can discuss about that later. But this is my idea, how we can use the crease pattern to compare two different models and try it the same or different. In some cases, different origamists can design very similar models, and in some cases the same, but different moments, different times, or different countries, or whatever. So what the main difference between diagrams and crease patterns? In diagrams, you have a flow. Each steps represents a way to fold the model, and usually it's a proposal given by the author or the person who make the diagram. There is multiple ways to fold a single model in most cases, not in all cases, but in most cases we can find there is different ways to fold the same model. And that's very interesting because we usually try to think that it's always follow steps, but in some cases we can find there are different ways to fold it. We usually find ourselves in origami meetings teaching origami model, and some person have another way to finish it or another approach to begin. Some people like to begin with the diagonal or with other crease. We have different forms. That is about diagrams, represents these step-by-steps. And crease patterns is more difficult to read, but it gives more information. It gives information about the structure of the figure. And this structure is talking about the design process, how is the base. We can give more detail or less detail in a crease pattern. So it depends on the person who diagram it, but usually it represents the most closest base to the finished figure. In this case, we have a diagram of a crane, and the other one is a more detailed CP of the same crane. Even is not symmetrical. If you can see, there is a crease from a wing in one side and in other side not. So that's the detail we can put in a CP or we can't put. So it depends how we want to show. The applications of origami and in particular using crease patterns can be applied in different areas of science and engineer, even in art. So this is a few examples. This is a solar umbrella, the first one. Another one is about trying to understand the wings of some insects are folded, so we can use the crease patterns and mathematical model to try to understand how these wings are folded into the insect. And even we can make robots of origami, like the other one, the top one, using these folds. And if you see in this one, all the analysis given using the crease patterns in more or less detail. Even in art, there is some examples that already is in exhibition are using crease patterns, not only as a way to share the origami figure, but also to use it as a art concept. And this is very interesting because it's moving forward from origami to the artistical way. This is from Sifo Mabona, the other one is from Johanna Williams, and both of them have been making exhibition using, in this case, the creases of the origami. About the origami software, usually we can find a lot of software. This is not the only ones that already exist. There are other ones very good online, but I only mentioned this particular origami software because we are going to talk today about some origami software and how I create this application. FreeMaker is for the designing of origami. It can be applied to make some designs. Reference Finder to pinpoint some given points in a paper and find how to find that reference point in the paper only using foldings. Oripa, we are talking about this particular software in this moment because it's very interesting because it helps to draw origami crease patterns. And rigid origami to simulate crease patterns. There are already others to simulate. And Rabbit Air is JavaScript library designed by Robbie Kraft. I think he's in the convention, I don't know. But it's really interesting. I'm not familiar with JavaScript, but I already trying to check it, and it's really, really interesting. And I think can be a lot of things doing with that library. Oripa, as
Andres, if you can speak with Robbie.
No entendí, perdón.
No, okay.
No.
And also Robert is here. Then later, maybe they can make you some questions. You can speak later
okay.
with them. Okay.
Really nice. Okay. Oripa, as I already told you, is really helpful to make origami crease patterns. And one interesting thing about Oripa is we can find that it uses coordinate systems to put all the creases as segments in a coordinate space. So this is only an example. We can find the coordinates. The center of the space is 0 for y and x, and each point represents when these segments crosses. So a segment is defined as two coordinate systems, and this is when I begin to use. When I discover, not discover, when I understand this, I see, okay, if we can use these numbers, this position of each crease, we can compare from one crease pattern to another the position of each of the segments of it. That means each of the creases from one crease pattern to the another one. So I'm begin to trying to find a way to compare each of these segments. So the main idea is this is the two. It's only a preview of what looks like a CP file. A CP file is a file that can be created in Oripa, and this is the structure of a file. You can find there is a column that defines the contour, the mountain fold, the valley fold, and the other numbers represents the position of each of the line segments of the crease pattern. So it have a start in X and a start and end in X and a start in Y and end in Y. Each line is a segment. And the other one that is the usually default file that we can save in Oripa is an OPX file. It's really an XM file. And not to be too complex, this is the same information is stored in this file. This is only a way I want to show you that I check the files internally, and we have the same information in both files, but in different configuration to show it. So I'm a biologist, so I'm not engineering, not system engineering or something like that. So my skills in programming are not so basic, but it's not as advanced other people. But in my head, it begins because this is the Koshu-Shiyama basis. It's very interesting because this is very close what I'm familiar in biology. I work with phylogenetics. I'm trying to understand the relationships between the animals, in my case, ants. I work with ants. And we usually make a phylogenetic tree that we can understand as evolutionary trees in which each branch represents a relationship between animals. So when I see these Koshu-Shiyama relationships of the basis, I think, oh, that's very interesting because I want trying to understand or compare each crease patterns, and he already make some of this, some kind of tree that is very similar I'm usually working. The relationship with these bases is already these segments of lines that are connected from define the more elaborate bases and more simple creases. I don't know if call it bases, but more simple creases. We can diagonal creases that combine it with medium creases. We create some of the bases. So this was very interesting, and in my head, that's what I'm trying to accomplish in some moment, but it began to change over the time. So if we have one question crease pattern, we want to compare this crane crease pattern to different kinds of crease patterns. We have a lot of crease patterns saved in our computer, and we want this crease pattern match with which of the other crease patterns. So using the same information I already showed you of the coordinates, we can check for the line segments and trying to see if the numbers is the same one or is different. And for that, we need to use some mathematical equations. I'm not going to go deep inside that, but I trying to understand some mathematical things. It's very simple, but I have to read a lot. And finally, I have a very helpful equation that is this one that I apply in my code, and I program it to make this, to compare all of the segments of the first crease pattern with all the segments of the other crease pattern. So we can, if a number of this comparison, we can find a number of similarities. Not is exactly a percentage of similarity, but it's a number that represents how similar these two crease patterns can be. So I make this in R. R is a very used language in biology, and that's why I'm familiar with this, and not with JavaScript or other languages, programming languages. So I use it R, and I combine it then with Shiny. Shiny is a R package that can be used to create a more friendly interface to an user. So I make the difficult part of trying to programming these comparisons with a given CP to a database of CPs. So I create a read function to read the CPs into the program, a function to compare the crease pattern with the other ones. There are these dependencies is the packages already designed by other people that is commonly used in R. That I use it to help this programmation of this. So this is what looks like the friendly version of pliegue double. We can find double fold is only a dumb name. I can think in a better name to this one. So this interface have different parts I'm going to show you. It's mainly designed to load a CP made in Oripa, in OPX or CP file, and it compares with a already existing database of crease pattern. This is very important, the database, because that's the limiting factor of this application, because we need to have a database of crease patterns. That is very difficult to have a lot of CPs already made in Oripa or something like that, but we are going to discuss it in the final part. So this is what looks like behind. This is part of the code. This is only some of the functions, but this is what look like really. I'm going to try to put online sooner so we can test it from all of you, and maybe give me some feedback, some ideas, or something. We can do it with this one. So we can choose the different databases. It is designed we can load different databases. In this moment, I'm using the ORIPA sample of CPs that is given in the program webpage. And Ryan Champ make a very interesting effort to make some like or crease pattern repository of about 200 CPs. And I already downloaded and use it to this comparison. So in this moment, this is the only database I have. Maybe in a moment we can increase the number and put a lot of more CPs to compare. The next thing is this is a threshold. The threshold means is we can filter our results. So if we put a threshold of 0, it's going to show us all CPs that has at least one segment match. If we put a threshold of 80, it's going to show you all CP that has given more than 80, it's like 80%, more or less. They have a error in the number, but about 80% from that place of similarities of the segments of the CPs compared. We can also check to use the mountain valley definition or not to use the mountain valley definition to compare the CPs. And this is for load the CP. And the input files from the moment, there are only ones to use is OPX and CP, but there are other files that I hope in some moment we can load in this program. And this is a place where the loaded CP is going to load. And this is what it looks like if we load a simple peer base loaded into the program. I'm going to show you how it works in a real demonstration, but this is only a screenshot. But I'm trying to show you how it looks. This is a threshold of 20, and this is 5 matches. If you see, this is, I don't know if you can see, but just above, up of all the matches, you can find an index number. If you see the first one is 100, the other ones are very low, 26, 26, 25, 20, 23. That's the number that show how many segments share with the input crease pattern. This is the first one. And also we have a table that with the same numbers, you can see there. This is using a 90, the same database, the same input file, but using a threshold of 90. You can see it only recovers one match in this case. That is the best one. And if we use a threshold of 20, but considering the mountain valley, it only gives one best match. So that's the difference of which initial configuration we put, what we can have as a result. So we are going to see in real life how it works. I'm going to load it from R. Oh, sorry. Okay. I have in here. I don't know if you are already seeing. No. Give me a moment. I think. So here it is. This is the selection of the databases. I have Oripa test I'm using, Rayasham, and this is, I'm going to talk about a rotation problem that I have. So we can put a really low threshold. I'm not going to use Mountain Valley in this moment. I'm going to find some this pattern. Is a simple crease base, not some complex on this case in the moment. And it will, in this moment, is comparing. In some cases, it takes time. In this case, I'm taking too long. Maybe it's by the connection we are using. So here's the, like we can see the first result. We have here the which base we use, the number of CPs in the database, the matching number, ready with at least one matching of segments, the threshold we use it, and the name of the best crease pattern matching. It corresponds to this first one. We can also try, I'm going to use some colors we can set here, and we can set that these show us which segments are the similars or has at least one part similar with the input crease pattern. This is very helpful because we already see this is the table of all the crease patterns that have already at least one match. This is not all of these 21 matching CPs shows because we can, this is a default of only plot for CPs. We can increase the number. I think I have a problem of size showing here. Give me a moment. So we have the first one, and we can increase the number in this case. We can use another test with another CP. We are going to use this one maybe. It's going to take more time because it's a more complex CP. I'm trying to optimize the time, but in this moment, I'm taking the time you are seeing I'm seeing in my screen is not in the same moment, so it's taking more time to. Okay. Oh, I don't know what's happening. I think I put a very complex CP. Give me one moment. Okay. I'm here because it's already in 55% of the matches is made. That's what's taking more time. So we need to wait a bit. This is a demonstration how to complex in this moment is the program, and I need to optimize this, but this is my first version, so it's already, the code is already difficult in some parts, so I need to optimize this better one. So it's only 80%, way up a bit. Oh, moment. This is, for me, this is very usual, because when I run phylogenetic analysis, we are making very complex computations, and in some cases it takes days. So this is really fast for me, and maybe for you it's taking time, but for me it's really, really fast. I don't know what I do. I think I changed the threshold. Oh, I don't know what's happened. Give me a moment. Okay, it's already close to finish. So as it uses all segment comparing with all the CPs that is in the database, this is already only one, because this is the only one that matches in the database, because it makes all comparison with all the CPs in the database. So it's the same one, because I'm already comparing already existing one in this one. So we are already using a 50% of threshold. It will really good to find which is the best CP in the database. So we make all comparisons, and finally we can find. I'm going not to close this one, but I'm going to do presentation. So what problem I have with this? Because all things I already show you an optimization problem, but all other problem I have is this one. This is the same CP, but only in different position. So as the way the program compares first CP with all the CP of the database, it usually do not have in account this problem, because we need to compare each of these positions with all the database. So make for comparison, because we don't know in which position is in the database or of this CP. So this is a very interesting problem I found recently, because I'm trying to use it with a friend and making some tests. And we find this problem. I think it can be solved in different ways. I'm trying to find which is the best one. I'm trying to understand this one, because it's the same CP, so in different ways. So if we input this CP, the first option can be this one, but in the database it's already the 4 position different, so it gives different numbers. I'm going to show you in the real program, as we can see how it works better. I hope you already understand me by my English. Sorry, I'm trying to be more clear as I can. I'm going to lower the threshold, and already going to load. So I load the CP I already showed you, only in one position. And I lower the threshold to see all the possible matches. And if you can see, the first one is 100%, but the other ones is 80, 66, and 57 of the index. So it's the same CP. The only is the position or the direct, the rotation of this trace pattern give off different results. So this is a thing I have to solve, but it's really interesting problem to make this in the program. That's one of the problems. And the other problems is about optimization, times, how to make with the connection. Hi. Hola.
Hola, yes?
Hola. Sí, sí. Ya me ven.
Okay, I think now we can go with the questions because I think we
have few time. Only I want to show only one thing, that is one thing I want to make in some moment, maybe a future project, is making an OLICP database from using in this one and in other things. So that's only a final comment I want to know. It's sorry that the connection was lost, but that's only the final thing I want to show you. You can make all questions you want.
Okay, I think you have the microphone, then we can start with the questions.
This is Robert Lang, and this is really neat. And I had a question about the underlying mathematics. It looks like you're computing. You're computing a function. That
I don't understand anything. Sorry.
Oh, is the volume not coming through, or the words? Can you hear me?
Yeah, I can hear you.
Okay.
Not so well, but I can hear you more.
Okay, slow.
Yeah.
It looks like you are calculating a distance equivalent between any two crease patterns.
Yeah, something like that.
And my question is the function that you are calculating, is it a metric in the mathematical sense?
Yeah.
So it satisfies triangle inequality?
I think I'm not so well with the mathematics. This is, I think I'm right to do with a lot of problems, so I'm trying to learn more. But yeah, I think my answer is, yeah,
Okay.
The triangulation problem, that I don't know.
Okay.
Hi, this is Robbie, Robbie Kraft.
Hi, Robbie.
It's wonderful to meet you, and this is just really exciting work. I want to stay in touch.
Really nice to be in touch with you.
Yeah. We just had like a 5-minute discussion while you were disconnected about just speculating about how your calculations work.
Yeah.
But
I can show you all the background of this with no problem. Maybe we can improve it.
I guess I was handed the mic. I didn't exactly have. Oh, so I am going to be talking about building an online database tomorrow, speculatively, and I'll be sharing a crease pattern editor that I have made. Actually, I can tell you it's at cp.rabbitear.org. I haven't announced it yet, but
really nice.
you can get the link ahead of time.
Really, really nice.
Yeah. Yeah. It's. No, I really. Oh, yeah. I did have one thing. Have you heard of the fold file format?
Yeah, I already see the fault
Did you ever?
file,
Oh shoot.
but
Okay.
I trying to understand how it works and something like that. But I begin this one with the CP and OPX, and then I find the fault. So I leave it for more in the time
Oh,
because
okay.
I begin working with these formats in the beginning. But I already seen, and this is very good format for this CPs because it have a lot of potential and information stored in that file.
Yeah, yeah. Okay, everybody's telling me that I was not paying attention during that slide, so I'm sorry. That was my fault. Yeah, there's they have converters now. So I'm primarily working in fold format, and I'm generating now a lot of files, because that's something that like both of our projects would benefit from, is a huge database of crease patterns, and I'm hoping that comes soon. And who, it was either you or Eric or Jason wrote a converter from Aripa to fold and back.
Yeah.
Eric wrote it. So yeah, we can convert between these all. So it doesn't matter what
It's just,
format it's in. Yeah.
Yeah, I think that's very helpful because it's already in a lot of formats already published online. So the people already can submit to this, I don't know, future database of CPs is already to do it. And I think this database has some like, I don't know, Flickr thing. We can see the image, but behind is the format, or I don't know, in fold format, something like that. And we can make this kind of analysis with the CP. And only this I'm showing with a lot of things that can be done with this information. And maybe the user can have control of information he's sharing, and a lot of things I'm thinking about. Usually in biology, we have already a lot of databases of information of genetics, biodiversity, what I'm very familiar. So, and I'm already using a lot of these databases from my work. So it's really helpful to have this kind of information online in a lot of CPs can be stored. So maybe it's a really interesting to think about this possible database. This is something I'm see when I begin to use this software.
Yeah, very cool.
Yeah, I don't know if you have any question. Maybe all people that are interested in this, I'm open to share my code, everything I have done from this point, because it was really difficult to me in some way to do it because I'm not working programming or something like that. But it was a question I have, and I want to solve by my way. So I can make this one work. So maybe we can improve it with other ideas from all of you. And with Robbie, I don't. Robert is here. I don't understand at the beginning.
We have one more question. Say your name and the question.
Okay.
Hi, this is Michał Kosmulski. It's very interesting, especially for geometric designs, where it's easy to accidentally rediscover something that has been done before. I was wondering how exactly you compare the segments. How do you tell that segments in two CPs are similar or not? Is it just about the coordinates?
Yeah, is if the segments intersect or parallel or are one over the other. So that's, I think, the three conditions I have programmed. So if it meets some of the conditions, the segments have a value of similar, or if this is not similar, in that condition, the two segments are not similar. So then I calculate the total of the this comparison between the two CPs, and that's the index I give that is going to 0 to 100. That's the way.
So for example, if I have several parallel creases and I kind of offset one half of the CP, to just insert some empty space, so to say, like in a tessellation, I can have pleats which can be longer or shorter. Does making them longer change the similarity score a lot or not?
No, the segment is more longer than the other one. Possibly this is a problem that usually it's going to say is the same one, because maybe it's a longer one over a more short. This is possibly showing that it's the same, but is different in the two CPs. That's a problem I have to solve, because we need to. It takes a same. So yeah, it's a problem. I don't know mention, but it's a problem.
And then to get the total score, do you compare all segments pairwise, like each one from the other CP? Because that probably results in very high computational complexity. So that's probably a point for optimization.
Yeah. It's a pairwise comparison, and yes, that's a problem to computation problem, because it takes time. I already show you how time takes time, but that's a problem.
Mm-hmm. Okay, so
maybe an heuristic. Maybe
lots that can be done. Okay, yeah. Thank you. I'm passing on the microphone.
Okay, thanks.
Okay, thank you.
Any question? More questions? Yeah, aquí abajo. Say your name and.
Yeah. Hi, I'm Roman Remme, and I've also been doing quite a bit of computational origami. Very cool project, and I really liked your the family tree of origami bases. And in our short discussion while we were online, I had this idea that maybe you could, with your software, automatically construct such a tree or maybe network of crease patterns out of existing models. Have you thought about this?
Yes, I'm thinking about that. As I already mentioned, that's the things I'm doing in biology. and yeah, I'm already thinking about making some trees. I don't know if we can relationship trees of crease patterns. Yeah, it can be doing using even these scores. Or maybe it can be used to make more the beginning of the searches, of the comparisons, more maybe optimized with that. At least at the beginning, maybe make groups of similar CPs and like some trees. And if not comparing with all trees, it begins with some branch, and it begins this pairwise comparison in these branches. So taking like a root of if it's more close to this group or this other group of CPs, it goes to this group, and maybe in subgroups begin to comparing each in these cases. Maybe that can be an idea to optimize these searches, but this is very complex to do, as I know.
Yeah, thank you.
Thanks for you.
Any question? If not, then no more. Then we say thank you to you, and yeah, okay, applause.
Really thanks for you. Really thanks for Ilan Igaviri and all of the convention organizers for giving me this opportunity to share this with you. And everyone who wants to contact me, I'm going to write in this moment my email, and you can write me to my mail, and we can talk about this more in person.
And thank you, and we hope the next convention you will be here and not via Skype.
I hope I can be more in presence.
Ok, gracias. Venga, hasta luego.
Thank you all. Gracias.